Hi everyone, in this video I'm going to present our paper, Open Set Semi-Supervised Object Detection. Semi-Supervised Object Detection have shown the promise of leveraging unlabeled data to improve object detectors. Previous works often assume the label space of label and unlabeled set are the same. However, this closed set assumption is unlikely to happen in practical scenario, where unlabeled images collected in the wild might contain out-of-distribution objects, which are unseen, undefined, and unknown in the label set. We are therefore interested in more practical problem, open set semi-supervised object detection, which aims to leverage unconstrained unlabeled images to improve object detectors. Previous works on semi-supervised object detection apply the self-chaining mechanism, which uses a teacher model to generate the pseudo-labels to supervise the student model. However, in the open set conditions, we find this work cannot perform well by using unconstrained data. We attribute this phenomena to the semantic expansion issue. To be more specific, when we use an object detector trained on label set and perform inference on the open set unlabeled data, some OOD objects are mispredicted as in-distribution objects with high confidence. Self-chaining methods cannot remove these incorrect predictions and use them as pseudo-labels. Adding incorrect pseudo-labels into semi-supervised training increases the false positive rate and makes the semantic expansion issue more severe. Therefore, to address the semantic expansion issue in the open set settings, we propose to add an additional OOD filtering in the existing SSOD framework. Specifically, we consider online and offline OOD detectors. Online OOD detection is to simply add additional branch on object detector for OOD detection. Offline OOD detection is to apply a pre-trained DINO and fine-tune with available label data, and it is distinguished from the object detector. We find the offline detection are better than the online detection, since online detection bundles two tasks, object detection and OOD detection on a shared encoder, and this makes these two tasks conflicting with each other. We also provide the empirical result on each method, and support that offline OOD detectors are generally better than online OOD detectors. We then apply our proposed frameworks to two different open set settings, including simulate scenario and large-scale unconstrained unlabeled data. For the simulate scenario, we randomly separate object categories into in-distribution and out-of-distribution classes and randomly sample different numbers of labeled data. We also find that our framework can suppress OOD objects while maintain in-distribution objects in the general pseudo-labels. And using our proposed frameworks with more unlabeled data can further improve the performance. For large-scale unconstrained unlabeled data, we use COCO as label sets and open images as unlabeled sets. We show that using our frameworks can improve object detectors trained on COCO datasets. We also show that it performs better than object detectors trained on COCO and open image label set. This shows that using our generated pseudo-labels is even more effective than using the ground truth labels in open images. In summary, we find open set semi-supervised object detection is a challenging problem, and the existing SSOD methods do not perform well in the open set conditions due to the semantic expansion issue. We then propose to add an OOD filtering in the SSOD framework and show offline detectors perform better than online detectors. This makes our proposed method significantly improve the prior works in three different open set semi-supervised object detection scenarios.